Advanced Financial Modeling, Topic 4, Multi-Period Portfolio Models, Learning Objective number 2. We're going to use time value of money functions and construct multi-period portfolio models with contributions and withdrawals, and use Excel's financial functions, and do a little bit with the rule of 72. So when we talk about a portfolio model with contributions, such as a problem like this, how much will you have in 40 years if you start with a $5,000 today and contribute $10,000 per year? That's 40 total payments, and that's end of period payments, and earn 5% a year. Well, to answer that question, we can use a portfolio roll forward, or we can use Excel functions. Let's do both. So I'm going to go to my spreadsheet. I have my parameters in here. I have starting balance $5,000 today, year-end contributions of $10,000, annual mean return of 5%, and 40 years. So I can do a portfolio roll forward, starting with period 0. That means today. 1 year from today would be period 1. So 1 year from today, that $5,000 will earn 5%. I'll anchor the 5%. And then I'm going to have a year-end contribution. So I'm going to add $10,000. So let's look at this formula. Portfolio roll forward in period 1 is the prior balance times 1 plus the mean plus a year-end contribution. Now let's talk about, if I had this as set up as a year, a beginning of year contributions, I would have to do the beginning balance plus the 10,000, all growing by 5%. But since these are year-end contributions, that $10,000 contribution doesn't earn 10% because it's at the end of the year. So I'm just going to hit enter, and then I'm going to copy this down, and you can see that my portfolio is growing every year, and after 40 years, in the 40th year, I have 1.243 million, 1,243,198. Now I could have used an Excel function, and you can see here the FV function, future value, where I put in the rate 5%, number of periods 40, payment minus 10,000, and present value is minus 5,000, and it gives me the positive value of $1.2 million. If I didn't put the negative 10,000 and negative 5,000, the future value would have given me a negative future value. So the FV function, PV functions are thinking about outflows and inflows. So if I put money into a portfolio, that shows as an outflow, and then the future value is a positive number. So I could have done it that way. This is by the way, this is just a simple idea of a portfolio roll forward. So let's talk about the next type of problem. Say you wind up 40 years from now with $1.2 million. And then the question is, well, how much can you safely withdraw? So you've retired on $1.2 million, which probably isn't enough for you, but we'll talk about that later. And you want to start withdrawing an amount of money for the next 25 years. So assume you're, say, 65 years old. This will take you to 90 years old. All right, you're going to start with beginning of period withdrawals. Okay, you have $1.2 million. You're going to start withdrawing an amount given today. The question is, how much can you withdraw for 25 years if you're earning if you continue to earn 5% on your portfolio and you had that $1.2 million? What we're going to do is we're going to start. What we'll do is we'll start assuming I'm going to withdraw $100,000 a year, and we'll see if that lasts me 25 years. And then we'll use a goal seek to try to figure out the amount I could safely withdraw. So back to the spreadsheet. I now have $1.2 million, and say I'm 65 years old, I'm at retirement, and I'm going to start withdrawing money out of the portfolio. So what we're going to do is our portfolio roll forward here with this withdrawal is I'm going to start with $1.2 million. I'm going to put that in a bracket because I'm going to immediately withdraw $100,000. Anchor that. Because I need to live that first year in retirement. I need cash at the beginning of the year, not the end of the year. And then that will grow at 1 plus the assumed discount rate, or return on our portfolio. So at the end of the first year, my $1.2 million in the portfolio, I take $100,000 out. That's $1.143 million, and then I earn 5% on that balance. So that's $1.2 million. Now I can copy this down. I'll just double click. And what you see is I run out of money in 19 years. Actually, 25 years from now, I have a deficit of $800,000. So the question is, how much could I withdraw to, on average, have my money last till I am till 25 years into retirement? So what you could do is go to Data, What If, Goal Seek. I want to set that year 25 portfolio balance to 0 by changing the initial balance, or I'm sorry, the annual withdrawal amount. So set that year 25 portfolio balance to 0 by changing withdrawal amount and hit OK. Notice that is $84,008 a year. That'll last me on average 25 years. So that's how I'm going to solve that problem. All right, so let's move on to the next part. So I want to try to use financial planning functions in Excel's PV function, payment function, future value function, number of period function, and rate function. The first one we've already done, that's the PV function. And that one, and here are the parameters for that function. For the PV function, you have to put in the rate, the number of periods, the payment amount, that's a periodic withdrawal or contribution. And then in brackets here, these are going to be the optional statements, which you could just not fill in, and that would be a future value and a type. A type has to do with when the payments are either at the beginning of the period or at the end of the period. If you omit it, it just assumes end of period payments. All right, so for the Excel PV function, I want to calculate that first. How much money will I have? I'm sorry, how much will you need at retirement if you'd like a $100,000 25-year annuity? So again, let's look at this problem. How much will you need at retirement if you would like a $100,000 25-year annuity? So initially, it sounds like I'm going to do an FV problem, but I'm not. Because what I'm going to do is think about time traveling. Time travel to you're at age 65. And at that age, you determine that for the next 25 years, I want $100,000 a year for 25 years. How much will I need at age 65 to make those payments to age 90? So what you're going to do is you're going to do a PV function, 25 payments of $100,000. I have a FV, I'm sorry, here's my 5%, here's my 25 periods, here is my $100,000 withdrawal, and also you want $10,000 left over for your funeral. So in this case, I want another $10,000 as an FV. All right, notice making these two negative, and what you see is you would need to save $1.4 million to ensure yourself 25 years of $100,000 plus an extra $10,000 to bury yourself. And I put a 1 here to make those beginning of period withdrawals in retirement. So that's how I can use the Excel function, by using the PV. Here's an example of a payment function. So you've already said that you need $1.4 million at retirement, which assume is 40 years from today. So say you're 22 years old and you want to retire at, say, 62. How much do you need to start contributing to a savings plan today if your savings plan earns 7%? Well, you can use a payment function. Now, the payment functions, you need to put the rate, the number of periods, or that's the number of payments, any amount you save today, that's the present value, and then the optional ones are future value, and the type is beginning or end. So in this one, what I've done is I've used the payment function. I put in 7%, 40 years. I put in a present value of 0, assume you've saved nothing today. And then under the future value, I put $1.482 million, and I made 1 here for beginning a period. So how much you're gonna, because I said how much you're gonna start saving today. And what that says is you need to contribute $6,491 into a savings plan annually for 40 years to ensure you have $1.48 million at retirement. So that's how I use the payment function. Another function is the FV function. So how much will you have in 40 years if you can only afford to contribute $6,000 a year starting today? So now I'm going to use the FV function, 7%, 40 years, $6,000 per year, and I put it a 1 here for beginning of period contributions, and that says I will wind up with $1.2 million, not my $1.4 million from before. And the NPER function, which is the number of periods. So this is a type of problem where you say, well, if you only save $1.2 million at retirement, how many years will my money last if I'm earning 5% and I'm withdrawing $100,000 a year? So in this problem, I do NPER as the function, 5%. I have my payment amount, that's going to be my withdrawals of $100,000. My present value, that's my $1.28 million I've saved. And I'm going to put 1 here for end of period, beginning of period. And what it says is my money is only going to last me 19.3 years on average. Not 19.3 years and not the 25 I was hoping for. The last thing we're going to do is just do something people talk about in finance called the Rule of 72. And that is, the Rule of 72 tells you roughly how many years it takes for your money to double based on the rate of return your money's earning. So if you take the number 72 and divide by the rate times 100, so if it's 7%, 0.07 times 100 or would be equal to 7. So if you're earning 7%, you're going to take your 72 divided by 7, which is going to be 10.29 years. So what that Rule of 72 tells you, if you're earning 7%, it will roughly take you 10 years to double your money. If you're earning 10%, I take my 72, divide it by 10, and I'll double my money every 7 years. If I'm earning 1%, I'll double my money every 72 years. So this is the Rule of 72 tells you. In the spreadsheet, I actually modeled it using the actual functions in Excel. So we can go to that. Got it right down here. Here's the Rule of 72, just taking 72 divided by the rate expressed as a whole number. But you can use the NPER function, number of periods function, and actually calculate it. And you can see the Rule 72 does pretty well. It pretty much guesses within 1 year of how many years it will take to double your money. So that's the Rule of 72. Also in the spreadsheet, you can see I have the functions we talked about, the rate function, the NPER function, the FE function, and I went ahead and tested it to show you and prove to you that those functions work. So for the example, on checking the FV function, we calculated $1.28 million. I went ahead and did a portfolio roll forward that exactly you would have that $1.28 million at the end of 40 years. And the number of period functions, how many years will my money last if I'm withdrawing 100,000, I have 1.8. I show you exactly that somewhere between the 19th and 20th year, your portfolio balance goes to zero. So this is good to see that those functions are working. Okay. So in this learning objective, we constructed a multi-period model and used a bunch of Excel time value of money functions to calculate some important personal financial calculations. In the next topic, we're going to create a full personal financial planning model.